How do we know if a set of data is linear, quadratic, or exponential? Well, we look at the changes that occur from point to point. So let's look at this first data set. We know what our x values are and our y values. And I ask myself, well, what happens to get from here to here and from here to here? On this side, I can see that every single time I'm adding 1. That's a very constant change. If I have a constant change down this side as well, then I'm pretty confident it will be linear. So to get from 13 to 7, I'd take away 6. To get from 7 to 1, I'd take away 6. From 1 to -5, I had to take away 6. And to get from -5 to -11, I took away 6. So when I have a constant change, then I know that this is linear. And I should always look for that constant change first. It becomes obvious pretty quickly when I look at the second example that to get from -28 to 63 is a different number than to get from -63 to -112. So when I go from here to here, I had to take away 35. If it were linear, then I would take away 35 again. But this time I'm taking away 49. And this time I'm taking away 63. And this time I'm taking away -14. Sorry, -77. So that's not constant. So I know it's not linear. Now what I can do is I can try to subtract a second time and see if there's a difference that's constant a second time around. So if I look for how to get from -35 to -49, then that was a difference of -14. I had to take away 14 more to get to -49. And I took away 14 to get to -63. And I took away -14 to get to -77. So on the second go around, my second change is constant. And that happens when we have an x squared or quadratic equation. And one easy way for me to remember that is the 2, I'm looking for the second change to be constant. Again, when I look at this third one, I'm hoping for a constant change. Take away 3, take away 12, or 6, take away 12. That's not constant. I could do it twice and it still wouldn't be constant. So it's not linear or quadratic. So the other possibility is that it's exponential. And exponential functions, remember, have a constant ratio. So we're looking for a number that we could multiply 3 by that would get us the 6. And the 6 by that would give us the 12. And if that's the same number every time, then we're pretty confident it's going to be exponential. So 3 times 2, -3 times 2 would give me -6. -6 times 2 would give me -12. -12 times 2 would give me -24. And -24 times 2 would be -48. If I have this constant ratio where I'm multiplying, then I have an exponential function. So anytime I have a set of data, I should look for either a constant change, adding or subtracting a number from one to the other, that would be linear, or if the first one is a constant, I would try it a second time to see if it was constant, then it would be quadratic. And if that doesn't work, I'd look for a number that I could multiply by. And if I can find a constant multiple, then I know it's exponential.